Okay, so we're going to work through our CSI question here for the journal. And this is similar, but not exactly the same values. So just watch that when you're doing your question. So our question is, there was a body found in a hostel, and we know that the body was found at 8 a.m. by a detective. And we know that the temperature of the body at this time was 28 degrees Celsius. And then an hour later, or 60 minutes later, we had a medical examiner came into the room and they recorded the temperature to being 23 degrees Celsius here. What we're interested in is finding out what time the victim died at. We're going to divide this question into two parts, but to start with, I'm going to sketch a diagram. So with wordy questions, we break it into little chunk sizes, and it's a good idea to sketch the diagram as well. So we're going to do a time graph here, and we know that at 8 a.m. here, which is T0, when the first person found the body, that the temperature was 28 degrees. So we're just going to put this in here, 28 degrees. And then at 9 a.m. here, 9 a.m., the temperature was recorded to being 23 degrees Celsius here. So we know that there's an hour's difference here, or 60 minutes here. What we can do is we can find out the rate at which the body cooled at, or the decay rate. And this here will be from here along here. And if we can find out what this K value is, we can work out then at what time the body would have been 37 degrees at the time of death. So we'll be using this K value then to extrapolate when we find this out back here. So we'll get a negative time to tell us what time was the body would the body die at. So we have all the bits that we need to find K, so we're going to identify those in the question first. So the formula that we would have used for other questions is n is equal to n0e to the kt. We can use something similar here. We're just going to replace n with theta for the temperature. So we have the 0, theta 0 for the 0 temperature. And then that is raised e to the minus kt here, because we're looking at decay. Now we've transposed this formula already in previous questions, where we know if we want to find k, it's going to be the negative log of theta over theta 0 all divided by t. So if you need to look back on videos on how to do that, you can find that out. So what we know is we know that the original temperature of the body was 28 degrees. And we know that theta, when somebody came to find the body an hour later, it was 23 degrees Celsius. And we know that the time was 1 hour, which is 60 minutes. What we're trying to find here is K. So we're trying to find the constant cooling rate of the body. We know our formula is going to be K is equal to the negative log of the temperature that it was found divided by the original temperature all over the time. And we can substitute directly into this equation. So it's the negative log of, and we have our temperature here is 23 divided by 28, all divided by 60 for 60 minutes. When we work this out, you can do it using Excel. You can see Excel here. This is how you would type it directly into Excel, equal to the natural log of 23 divided by 28, all divided by 60, and it's a negative natural log there. Or we can just type it into our calculator, and we get a K value as 0.0032785. And then this to three significant figures would be not significant, not first significant, second, and this would become 8 here, and that's per minute. So we now have our K value. Once we know our K value, we can extrapolate back to this part of the graph here to find out the time here when the body was 37 degrees. So we're going to take this K value and use it as one of our knowns for the next part. K is equal to 0.0032785. 328. We know that the original temperature was 28 degrees Celsius, and we know that theta, we're trying to find out when the body was 37 degrees. Again, the time is what we're trying to find out, and we expect this to be a negative value and then work back from 8 in the morning. So we'll use our formula. T is equal to the negative log of the temperature divided by the initial temperature, all divided by K. If we substitute in directly, it's going to be the temperature here is going to be 37 when the body died, all over the original when the person came into the room, found the body, divided by 0.00328. When we work this out, it gives us a negative value of minus 85.025, and we round this up to the nearest minute, which is minus 85 minutes. Now again, if you wanted to type this function into Excel, you could do it directly here like this. So we can now work out from our graph that somebody died 85 minutes before 8 o'clock in the morning. And so if we extrapolate back, we know that 85 minutes is the same as 1 hour and 25 minutes. And so 1 hour would be 7 o'clock. And then if we take another 25 minutes before that, it would be 6:35 a.m. when the body was 37 degrees Celsius.